In this video segment, we're going to look at Section 2, Problem 2. And in this problem, we have Lauren, moderately skilled white-collar worker, so administrative, somehow not a manual laborer. Lauren has a utility preference, so that is a function of monthly income, some risk, and some leisure. And her utility preference can be expressed with this, this equation, U equals Y times the square root of leisure divided by R, or income times the square root of leisure divided by risk. And this would be Lauren's utility curve. Everyone's going to have a slightly different utility preference. Some are going to be more highly weighted income, some more highly weighted leisure, some less risk, etc. And so she's facing a decision from 3 different employers. How are we going to make the decision here? Well, what we're going to do is we're going to look at each of the 3 different employers, firm A, B, and C. We're going to put into Lauren's utility equation the different values. So wage and benefit in firm A is $5,000, so that's Y. Working environment with enough inconvenience to warrant a risk factor of 5, so R is 5. But the position includes leisure time for a value of 25, so it's then LE is 25. So this is going to be 5,000 times the square root of 25 divided by 5. Well, not coincidentally, the way I set this up, when you look at it, the square root that we have for each one of these is going to be such that we end up simply with the utility being equal to the wage that can be identified here. I just set it up for convenience, but you would have had to have calculated each of them to see this. So as you look at each of them, we see then that for firm A, Lauren has a utility value of 5,000. For firm B, a utility value of 4,000, and firm C, a utility value of 4,500. So the first question then is analyze the utility level for each of the 3 firms and provide her level of expected utility for each. So we've done that. 5,000, 4,000, and 4,500. And since as rational economic actors or agents, we always want more utility than less, I think we can surmise that Lauren would prefer to have the job with the greatest level of utility, or job A. So in part B, I then say, for which of the 3 firms would you expect Lauren to accept an offer? Well, just as I said, she's going to be choosing A because A at 5,000 is greater than C at 4,500, which is greater than B at 4,000. So she's going to choose A. Then in part C, I've said, okay, provide a compensating wage differential model in wage and risk space, so wage and risk, of the decision Lauren makes. So Lauren is one consumer, one worker with one utility preference. So I've given a curve, one curve for utility preference. But since there are 3 firms, each of them will have their own isoprofit curves. And recall that on an isoprofit curve, that profit is constant for that firm. And in this case, we typically think of this as being constant at 0. But for the next firm, it's also constant, and the next firm, it's also constant based upon how these firms are structured things. And then Lauren is going to choose to work for the firm where she has a match between her utility preference and what the firm is offering, and we would see that match, or that tangency develop here, where we have a risk level of 5 and a wage level of 5,000. So this is how you would have motivated this. This, as it turns out, I thought was the easiest question on the entire exam. Surprisingly few of you chose it, and I'm guessing because you just weren't terribly comfortable with motivating the utility equation, which is really not all that difficult an equation. It is a little bit different than any you'd seen, but only by its algebra. Conceptually, this is exactly like one of the other questions you've seen on review problems and in the modules. So then in part D, I said, okay, describe in as much detail as you can the nature of the curves reflecting the worker's preferences and firm's condition. And be sure to specify commonly used names, etc. So the indifference curves, the constant level of utility at any point. The indifference curves are convex in wage and space and risk space. By the way, that means they're concave in wage and benefit space, which is what we often see them at when we're doing an optimality of some kind. And then they're monotonic, so they start in a direction and they keep going in that basic direction. And utility rises as curves as the curve moves up and to the left in wage and risk space. So actual profit curves, constant level of profit at any point. They're monotonic, they're concave, or they're shaped like an opening of a cave in wage and risk space, and the curve shifts to the right as the level of profit rises. So you see that we've given a curve that is convex and some curves that are concave that meet the rules that I've identified here. So some of you gave very good descriptions here. Some of you hit many of these in which you got full points. Some of you hit most of them, so maybe a small deduction. Some of you had struggled with this part, and the scores are shown appropriately.